Hello everyone, welcome to my channel Arthashastra Classes. In this video, we are going to solve a very important numerical. This is the question as you can see on your screen. This question was asked last year in December 2019 term and examination and we will solve it. Before solving it, I request you to solve with me, and for this you need a pen and of course a practice notebook. So the very first step in solving a numerical is to write down the given information. As you can see on your screen, first we write down the given information. We are given the utility function u, a function of x1 and x2 as x1 raised to the power alpha, x2 raised to the power beta. This is a standard form of Cobb-Douglas utility function. Here x1 is good 1, x2 is good 2, and alpha and beta are positive constants. Another information which is given to us is related to budget constraint. We are given P1 as the unit price of good 1 x1, P2 unit price of good 2 x2, M income of consumer. So we can write down the budget constraint as P1 x1 plus P2 x2 less than or equal to M, where M is the total amount that a consumer can spend on the consumption of both goods given the prices of two goods. So the first question which is asked in this question is to find out uncompensated demand functions. Uncompensated demand functions are also known as ordinary demand functions, WALRASIAN demand functions, MARSHALLIAN demand functions. You might encounter any of the term in the examination. So we will solve for uncompensated demand functions now. While solving for uncompensated demand functions, we first need to set up the utility maximization problem. So we write down the step 1 as set up the utility maximization problem or UMP. Let's first understand what we mean by a utility maximization problem. It is a problem of a consumer, a rational consumer who aims at maximizing his utility. That is the utility which he derives from the consumption of two goods, x1 and x2 in our case, subject to his budget constraint. That is, given the prices and income, how he can maximize his utility from consumption. This is what essentially a utility maximization problem captures. So our objective is to maximize utility function subject to budget constraint, which we write numerically, or we can write objective is to maximize x1 raised to the power alpha, x2 raised to the power beta, such that P1 x1 plus P2 x2 is equals to his income, that is M. Our another constraint is x1 and y1, or you can write it x2 should be greater than 0, that is consumption is non-zero and non-negative. Our next step involves setting up the Lagrangian function for our constraint utility maximization problem. Now, why we set up the Lagrangian expansion? Our objective is to maximize the Lagrange expansion by optimally choosing the quantity of good 1, that is x1, good 2, that is x2, and lambda, where lambda is what? It's an unknown Lagrangian multiplier which we will determine through our utility maximization problem. Note that lambda is a positive constant and hence greater than 0. So we set up our maximization problem as maximum Lagrangian, L stands for Lagrangian over here, is equals to maximum utility of x1 x2 plus our budget constraint, so lambda m minus p1 x1 minus p2 x2. So we have written our budget constraint and a utility function. Now in our case, Lagrangian becomes x1 raised to the power lambda, x2 raised to the power beta plus lambda m minus p1 x1 minus p2 x2. Our third step is to find out the first order conditions. Whenever we solve a maximization or a minimization problem, we have to find out two conditions. First, the first order conditions that involve first order derivative, and the second order conditions which involve second order derivatives. So we will start by finding out the first order condition, and as you know, in first order condition we differentiate the given function with respect to various variables which are there in the function. So in our case we have three variables, x1, x2 and lambda. We will differentiate L to get the first order conditions. So differentiating Lagrangian function with respect to x1, we will get, okay, let's first expand the derivation notation. We write it as d, or because it's partial derivative, so we will write del by del x1 of, matlab we are derivating the utility function first with respect to x1. So here x2 raised to the power beta is a constant. We write it before x2 beta, and since we are going to differentiate x1, so x1 raised to the power alpha. On differentiating x1 raised to the power alpha, we will get alpha x1 raised to the power alpha minus 1. Now differentiating the remaining term, that is lambda times m minus p1 x1 minus p2 x2. Since lambda is in multiplication, we write it as it is, and now differentiating the term in bracket with respect to x1, we will get m is a constant, it will become 0, minus p1 x1. On differentiating this term with respect to x1, p1 is a constant, so it will be, and it's in multiplication, so it will not become 0, it will remain p1 only, and x1 differentiation with respect to x1 is 1, and minus p2 x2 will become 0. So we will get minus lambda p1. So the whole differentiation of the Lagrangian function partially with respect to x1 will be x2 raised to the power beta times lambda times x1 raised to the power lambda minus 1 minus lambda p1. Okay. Similarly, we can differentiate the Lagrangian function with respect to x2, and we will get x1 raised to the power alpha times beta times x2 raised to the power beta minus 1 minus lambda p2. Differentiating the Lagrangian function with respect to lambda, we will get m minus p1 x1 minus p2 x2. Now we have find out the first order derivatives of Lagrangian with respect to x1, x2 and lambda. Our next step is to set the first order derivatives equal to 0 so that we can solve for optimum values of x1 and x2. Setting up the derivatives equal to 0, we get the equations 1, 2 and 3. In this equation we have just put the derivative equal to 0, and the term minus lambda p1 has been transferred from LHS to RHS, and same for the other two equations. Now we have our three important equations. We will start for solving for x1. So to solve for x1, we divide the equation 1 by equation 2. We have del L by del x1 divided by del L by del x2 equals to lambda x2 raised to the power beta x1 raised to the power alpha minus 1 divided by beta x1 raised to the power alpha x2 raised to the power beta minus 1 equals to lambda times p1 divided by lambda times p2. So lambda cancels out. We are left with the expression on your screen. Now we rearrange the expression by writing x1 and x2 terms together, we will shift our x1 term from numerator to denominator and our x2 term from denominator to numerator. So we will get the equation 2, that is lambda by beta x2 by x1 equals to p1 by p2. Now this equation is of prime importance as it captures the equilibrium condition of consumer theory, which is nothing but marginal rate of substitution of good x2 and x1 should be equal to price ratio of two goods, that is p1 and p2. Okay, now we solve for x2. We can solve either for x2 or x1. So I have solved it for x2. By rearranging the above expression, we get the equation number 4, which is x2 equals to beta by alpha times p1 by p2 times x1. Now to solve for x1, we will put this expression of x2 in equation 3. So putting equation 4 in equation 3, we get p1 times x1 plus p2 times x2 equals to m. p1 times x1 plus p2. In place of x2, we are going to put the value of equation 4 and we write it as beta times p1 divided by alpha times p2 whole times x1 equals to m. p2 cancels out. We are left with p1 x1 plus beta by alpha p1 x1 equals to m. We take p1 x1 common and we write the remaining terms in bracket as 1 plus beta by alpha equals to m. On solving the term in bracket, we get alpha plus beta over alpha. On rearranging the above term, we get p1 x1 equals to alpha over alpha plus beta times m. Now solving for x1 gives us x1 is equals to alpha over alpha plus beta whole times m over p1. Now I have put a star over this because this is our uncompensated demand function for good x1. Yes, we have found out the uncompensated demand function. Now to find out the uncompensated demand function for good 2, we put the value of x1 star in x2, and on putting the value and doing some calculations, we will get x2 star as beta over alpha plus beta whole times m over p2. So this is our uncompensated demand function for good x2. Now we write them separately and we represent them as x1 star is equals to x1 star, a function of p1 p2 m, that is the income of the consumer, equals alpha over alpha plus beta times m over p1. This is our uncompensated demand function for good x1, and x2 star as x2 star p1 p2 m equals to beta over alpha plus beta times m over p2. This is our uncompensated demand function for good x2. In this question, we have not been asked to find out the uncompensated demand function for lambda, which represents our budget constraint, so we have not written it. Okay, our next part is the indirect utility function. We are asked to find indirect utility function for this consumer. So let's see what is indirect utility function. The indirect utility function is defined as the maximum utility that can be attained given money, income and goods prices. Okay, so what is the standard notation of indirect utility function? This standard notation is very important and you have to write it in your papers. So it stands for V, a function of P1 P2 M. Here V is a notation which we use for indirect utility function. Remember, we use the alphabet U for utility function and alphabet V for indirect utility function. So a function of U, x1 star raised to the x1 star, a function of p1 p2 m, x2 star, a function of p1 p2 m. We have seen that uncompensated demand functions or ordinary functions or WALRASIAN demand functions or MARSHALLIAN demand functions are functions of price of the two goods and income of the consumer. So, how we can find out the indirect utility function? We just have to put the uncompensated demand functions in the utility function and we will get our indirect utility function. So in simple terms, what we have to do, we just have to put ordinary demand function in the given utility function to find out the indirect utility function. So our function is u x1 x2 equals to x1 raised to the power alpha times x2 raised to the power beta. We substitute x1 x2 by x1 star or x2 star, where x1 star and x2 star are the ordinary demand functions or the uncompensated demand functions. So we substitute them, x1 star raised to the power alpha, x2 star raised to the power beta, or we can write it as u, a function of x1 star and x2 star, as alpha over alpha plus beta into m by p1 whole raised to the power alpha times beta over alpha plus beta into m over p2 whole raised to the power b2. So this is the required indirect utility function. We can solve it further, but it's not required because we have been asked the indirect utility function and we have derived it, so no need to solve it further because it's time consuming and not required. Okay, in our next part we are asked to find the compensated demand functions. Compensated demand functions are also called HICKSIAN demand functions. Now what is the difference between compensated demand functions and ordinary demand functions? I will explain in detail in the theory class of this topic, but for numerical just remember this: a ordinary demand function is a function of prices of two goods and the income of a consumer, whereas a HICKSIAN demand function is a function of prices of two goods and a constant utility u bar. Okay, so the procedure for finding out the compensated demand function is more or less same. The only difference is that in ordinary demand function we set up the utility maximization problem, while in HICKSIAN demand function we set up the expenditure minimization problem. See, there are two things while we are talking about consumer theory. First, a utility function, and other is the budget constraint. So in finding out the ordinary demand function, we have focused on utility aspect, that is we are focused with maximization of utility, and while finding out HICKSIAN demand functions we are focused on minimizing the expenditure of the consumer. Expenditure minimization problem, we are concerned with the problem of a consumer who aims to attain a constant level of utility and his objective is to minimize his expenditure. That is, there is a constant level of utility which he aims to achieve, and in what minimum expenditure he can attain that utility, we discuss this problem in expenditure minimization problem. So we set up the minimum expenditure equals to P1 x1 plus P2 x2 subject to the utility constraint. Here constraint is of utility, and in ordinary demand functions constraint was of budget. His expenditure was the constraint and objective was to maximize utility. Here his constraint is utility and his objective is to minimize the expenditure. As I told you in the beginning of this video, that while solving any maximization problem or minimization problem, steps are the same. So we will find out first the first order conditions, then we will set the derivatives equal to 0, and we will solve for x1 and x2. So our second step is the setting up the Lagrangian function for AMP. Here our objective is to minimize the Lagrangian expansion by optimally choosing x1, x2 and mu. In ordinary demand function we took lambda as the Lagrangian multiplier. Here we are taking mu as the Lagrangian multiplier. Now we set up our Lagrange as minimum L is equals to minimum of p1 x1 plus p2 x2 plus mu u bar minus x1 raised to the power alpha times x2 raised to the power beta. Here u is the constant level of utility which a consumer wishes to attain. Next step involves finding out the first order conditions. As we did, we are going to repeat the same process and we will find the derivatives. So differentiating p1 x1 with respect to x1, we will get p1 being a constant, it will be p1 only, and differentiation of x1 with respect to x1 will become 1. Differentiation of p2 x2 with respect to x1 will become 0, and differentiation of u bar will become 0 minus x1 raised to the power alpha, which is a utility function. We have already derivated our utility function with respect to x1 and x2, so the same term will come here. Again, now setting the first order derivatives equal to 0, we will get the equations 7, 8 and 9. These equations are again very important, so we will mark them. Now, following the same steps as we did earlier, we will solve for any one of the good, that is x2 or x1. For this we divide equation 7 by equation 8, and on solving we will get p1 divided by p2 equals to alpha by beta times x2 by x1. Note that this is the condition which we derived earlier as well. Why so? Because this is the equilibrium condition, and no matter how we derive by utility maximization problem or expenditure minimization problem, it will remain same. Okay, so we mark this equation as equation 3rd. Now we get the value of x2 in terms of x1. We mark this equation as equation number 10. Now to find out the value of x1, we will put equation 10 in equation 9. So we have x1 raised to the power alpha times x2 raised to the power beta equals to u bar as an equation 9. Substituting for x2, we get x1 raised to the power alpha beta times p1 over alpha times p2 into x1 raised to the power beta. Now we can take out x1 and we can arrange the two terms of x1 together. See, whenever we are using the exponential rule, a raised to the power n times a raised to the power m, if bases are same, we can add on the powers, so it becomes a raised to the power n plus m. So applying the same rule, we can add the powers alpha plus beta as the base x1 is same. So we get x1 raised to the power alpha plus beta into beta times p1 over alpha times p2 whole raised to the power beta equals to u bar. Now solving for x1 we get x1 raised to the power alpha plus beta. Taking the constant term to the RHS side, we get its reciprocal. We get u bar over alpha by beta p2 times p1 whole raised to the power beta. Now we wish to remove the power from x1, so what we will do, we will divide both LHS and RHS terms by the power 1 over alpha plus beta. So on dividing we get alpha plus beta by alpha plus beta, so it cancels out and becomes 1. So x1 raised to the power 1 equals to u bar alpha by beta p2 by p1 whole raised to the power 1 over alpha plus beta. Taking out u bar outside the bracket, we get x1 star as u bar raised to the power 1 over alpha plus beta alpha by beta p2 by p1 whole raised to the power beta over alpha plus beta. Now this is our HICKSIAN or compensated demand function for good x1. Similarly, we can find out the function for x2 by substituting the HICKSIAN function of good x1 in x2 in equation number 10. So substituting x1 star in equation 10, we get the value of x2 star as this. Now as we can see, the term beta times p1 divided by alpha over p2 is the reciprocal of the term in the bracket alpha over beta p2 times p1. The terms beta times p1 over alpha times p2 and alpha times p2 divided by beta times p1 are reciprocal of each other, so we can take them out and we can add on their powers so that we can simplify the expression. So we write down beta over alpha into p1 by p2. Its power is 1, so we write 1, and we do the reciprocal of the term. We get beta by alpha p1 by p2. See, since the power was beta over alpha by plus beta, on reciprocating the term a minus sign comes and it becomes minus beta over alpha plus beta. Now the bases are same, so we can add on the powers. 1 minus beta over alpha plus beta. On simplifying this, we get alpha plus beta as the denominator, alpha plus beta minus beta, beta beta cancels out, we are left with alpha over alpha plus beta. So this simplifies our expression, and the final expression we get as x2 star equals to u bar whole raised to the power 1 over alpha plus beta times the term beta times p1 over alpha times p2 whole raised to the power alpha plus alpha divided by alpha plus beta. This is our HICKSIAN demand function for good x2. We represent the HICKSIAN demand functions as x1 star equals to h1, where h stands for HICKSIAN, a function of p1, p2 and u bar, a constant utility term, and it is on your screen. So we have solved for all the 3 parts. If you find this video helpful, then please like it, share it with your friends and subscribe to my channel for more such videos. If you have any confusion, doubt or any suggestion, you can put your comments in the comment section below. I will try my level best to solve your doubts. Thanks a lot for watching this video.